All right, let's jump right in. We're going to take a trip out about 1,360 light-years from home, to the constellation Vulpecula. Our destination? One of the most famous objects you can see in the night sky, Messier 27, also known as the Dumbbell Nebula. And let me tell you, it's not just beautiful, it's hiding a secret that's making scientists rethink pretty much everything they thought they knew about how stars like our sun die.
I mean, just look at it. Things like the Dumbbell Nebula are called planetary nebulae, and they are absolutely breathtaking. You first see this incredible, almost perfect symmetry, but then you start to notice the details, these delicate, wispy structures inside. It's this amazing mix of grand design and intricate complexity. They really are some of the most gorgeous things in the entire universe.
So what even is a planetary nebula? Well, first off, it has absolutely nothing to do with planets. Nope. It's what happens when a star that's kind of like our own sun gets to the very end of its life. After it's all out of fuel, it basically shrugs off its outer layers of gas. You can think of it like a gentle, slow-motion explosion that leaves behind this beautiful, glowing cloud expanding out into space.
Now, for a long time, scientists had a pretty solid theory about how these things form. You know, it was the standard textbook explanation that pretty much everyone agreed on. So let's take a quick look at that standard story.
Okay, so it's called the interacting winds model, and it's pretty straightforward. Step 1, the dying star puffs its atmosphere away in a slow, lazy wind. We're talking only about 10 kilometers a second. Step 2, the tiny, incredibly hot core of the star is now exposed, and it unleashes this crazy fast wind, blasting out at something like 1,000 kilometers a second. And step 3, this super fast wind plows into the slow wind, creating a massive shock wave that lights up all the gas and, bam, you get the beautiful nebula we see. It's a nice, elegant theory.
But you know, science isn't about just accepting theories. It's about testing them. So a team of astronomers pointed the powerful Fuse and Hubble space telescopes right at the Dumbbell Nebula. They were going to take a super detailed look at the gas inside, expecting, to find all the proof they needed to confirm that interacting winds model was right on the money.
And the one thing they were really looking for, the key piece of the puzzle, was that super fast wind. That 1,000-kilometer-per-second blast coming from the central star. I mean, that's the engine that makes the whole theory work. It's the smoking gun.
And they didn't find it. Not even close. The fastest stuff they could find was moving at like 70 kilometers per second. 70, that's not a little rounding error. That's more than 10 times slower than the theory said it should be. Right away, they knew something was seriously wrong here.
And this is where the whole story just gets completely wild. The theory says you need a fast wind, and that the most superheated, high-energy gas should be moving the fastest. But what they actually found in the Dumbbell Nebula was the total opposite. The wind is slow, and the most energized, zapped-up material is actually moving the slowest of all.
Yeah, you heard that right. The whole thing is basically upside down. The gas that's getting blasted with the most energy from the star is just crawling along, while other material that's less energized is moving faster. It just completely flips the script on the standard model. It's a real head-scratcher.
And look, this isn't some small little detail we can just ignore. These discoveries are a direct challenge to the fundamental way we thought these nebulae were built. The story we've been telling for decades just doesn't match what we're seeing in M27.
The scientists who found this didn't mince words. Back in their 2007 paper, they put it very simply. These observations are a challenge to the interacting wind model. And that's what science is all about, right? The evidence showed that one of our main theories needed a major overhaul.
But wait, it gets even weirder. That whole upside-down structure wasn't the only surprise hiding in the Dumbbell Nebula. As astronomers kept digging into the data, they stumbled upon another puzzle, something they call the molecular paradox.
Okay, try to wrap your head around this one. So they found delicate little molecules of hydrogen gas just hanging out inside the nebula. Now, in that environment, with all the heat and intense radiation, those molecules should be torn to shreds in an instant. The only way we know for them to survive is to hide out on tiny grains of dust. The dust acts like a little shield. But when they looked at the light from the star, it wasn't being blocked or reddened at all, which is what you'd see if there was a bunch of dust in the way. So you've got these fragile molecules that shouldn't exist with none of the protection they need to survive. It's like a magic trick, and nobody knows how it's being done.
And this is why this one object, Messier 27, has become so incredibly important. It's more than just a pretty picture in a telescope. It's a real-life cosmic laboratory that is actively testing our best theories and breaking them.
So the big takeaway here is that the Dumbbell Nebula isn't just some weird one-off. It's a wake-up call. It's forcing astronomers to go all the way back to the drawing board and rethink some really fundamental ideas about how stars like our Sun live and die. It just goes to show you, even with objects we've been looking at for centuries, there can still be huge secrets waiting to be found.
And that really is the Dumbbell Nebula's biggest secret. It's a powerful reminder that science is never really settled. It makes you wonder, right? If an object this famous, this well-studied, can just turn a major theory on its head, what other incredible secrets are out there, hiding in plain sight, just waiting for us to ask the right questions?